Okay, this problem is rotate an array. So it is a right rotate. It is asking like one integer array is given num, so to rotate the array to write by k steps. K is a non-negative value. It could be a rotated array, rotated string, anything. So it is simply rotated. It is a good thing, and we will learn here left rotate and right rotate both cases. And here, though it is mentioned as right rotate, I will say it will be right rotate, but I will also teach you how to do the left rotate, and we will find a nice connection between left rotate and right rotate. Okay, so for that, let's do it. So for this, what I have to do is mm, okay, let's take an example here. Okay, this is a simple example. K equals to 3. If I rotate right side, 7 comes once here. Rotate one step, 7 comes this side, right side. So it will come this side and to this side. 7 comes here, and the rest of the element is shift one side to right. So here, then our second rotation, 6 come outside and ends at this side. This is one. And one thing is like here also, like 4 comes here, like 5 here, 5 comes out, and 5 comes inside from this place. Let's see what are the methods we could use to do this problem. Okay, okay then. So let's start. First, focus on left rotate. Left rotate. Okay. List my array is 1, 2, 3, 4, and 5. If my k equals to 1, that means left rotation. Am I started the recording? Yeah. So if I do like this place will comes this side, and after that this all elements move to the one step left. So if I do k equals to 1, this array will be what? This new array will be everything goes to right 2, 3, 4, and 5, and 1 enters at the end. Again, if k equals to 2, add in 3, 4, 5, 1. Okay, one thing, okay, I forgot to mention the constant. Constant, see what? Constants 10 to the power 5, okay. And now k will be what? K is 10 to the power also 5. But don't think k is same equals to length, nums of length. Why I'm saying that? See this one. If my take another example, k, sorry, not k, array. Assume my ARR is what? 0, 1, 2, simple 1, 2, 3. Now, if I do right rotate, as the problem is right rotate, I'm explaining about right rotate, then I will come out with the left rotate again. So, if that is the case, see what is the problem. So, if my k equals to 1, I have to right rotate once, right? So, array will become 2, 0, 1. Okay, isn't it? So, if I do k equals to 2, it becomes what? 1, 2, 0. Then if I do k equals to 3, it becomes again 0, 1, 2. Okay. Again, if I do k equals to 4, see this, it becomes again 2, 0, 1. Again, so here, see here, I can do any times of rotation, 4 times, 5 times, 6 times. So it doesn't matter. Like if my array length is 3, I can do rotation more than 3. It could be 5, 6, 7, 8, 9, 10 to anything. Okay. So is there any pattern? Do you have to do rotate, or can you find a pattern? Can you reduce the value of k? Okay, for that, let's write some of the more value. Like k equals to 5, it will becomes again 0, 1, and 2. And if k equals to 6, it will becomes again 0, 1, 2. Now see this for whenever k is multiple of 3, that is the same pattern, right? 0, 1, 2, 0, 1, 2. Even when k is 1, when k is 1, 201. This pattern is comes at 201 again at k equals to 4. What could be the relation between that? And we can also say like this is k equals to 0, right? Like no rotation. K equals to 0 is no rotation. So what would be the value? What is the case? In this case, so in this case, can you see 1 and 4? Could you see any kind of any connection? So 1 plus 3 is 4. And if I do the k equals to 7, you can see the same value. So you can see if I remainder, if we notice about remainder, if I divide 1 by 3, how could I get the 3? 3 is the length of the array. If I divide a by 3, remainder 1 by 3, it will be, remainder will be 1. Similarly, if I do 4 divided by 3, remainder will be 1. Similarly, if I do 2 divided by 3, remainder will be 2. Even the 5 divided by remainder will be 2. So this is the same again at 2 and 5. So what can we notice? Whenever my remainder is same, the pattern is same. So if it is given as 5, I can do only one, like only 2 times rotation, right? Why should I rotate 5 times? So I can reduce the value of k, right? So it will be actually, if the remainder is same, my output will be similar, right? So what we could do, we can reduce the then value of k. You can reduce the value of k by k modulo n. Okay, it is also applicable for the left rotation as well. So this is the thing. So this is what like, and let's come back to the our left rotation part. So here we could see like this is a left rotation, as I just said it. This is how it works. For example, I am taking for now that k equals to 2 for left rotation. In that case, this is my output array, correct? This blue color is my output array. So is there anything we could do? Like simple, let's do the what they said. Let's do what they said. They said what? Take the first element, remove it, add it the behind. Take the second element, remove it, add in the behind. We could do like that. And there's a good data structure for that. We are removing from the front and adding from the back. What is the data structure? It's a queue data structure, right? So what I could do, like, and how many times I have to do that? 2 times I have to do that, or kth times I have to do that. So what I can do, I can create a queue with this array, okay, and do these times of pop out 1 times and push it into back, and how many times? K times, okay. So we can do like, so if I take a queue like this thing, so 1, 2, 3, 4, 5. If I do the pop first element and add at the back, so 5, 1. Okay. So this is after my first rotation, right? It is after my first rotation. If I pop 2 and add into the back, this is my second rotation, right? If I pop 3 and add into the back, this is what? This is my third rotation, isn't it? This is my third rotation, isn't it? So this is one way we could do that. So let's try to find a pseudocode of it. So what I need actually, I need a queue. First of all, I need a length of the my array. So n equals to arr dot length as always. Okay. Then what I have to, as I told you, I need a queue. So queue, I am initializing a queue. If there is a queue data structure, use the queue data structure, or you can implement the queue. So I'm, as long as the queue data structure is there, queue. I'm initializing a queue. So now I have to put each and every element into the queue. Okay. So I have to do what? For each element for x into the arr, for each element of arr, what I am doing? I am simply adding that queue dot add or pushback, whatever the your function is, it is x. I'm appending the element into the queue. Okay. After that, what I said, I have to take out the first element and push it into the back, correct? So what I have to do, like so not for, how many times I have to do? K time I have to do. So what I can write, while k is greater than 0, I can do the same thing. What I have to do, like x equals to q dot pop the front element, of front and q dot add x. This is the thing. And what another thing I have to do? Done one times, so k minus minus. This is what I can do. And I have to now convert this q into my ARR, actual array. So I can do like I can initialize I equals to 0 and for how many times I know n time it is there for I in, or I can directly like this thing, 5 elements are there or n elements are there, so I can write another for loop for my I equals to 0, I less than n, I plus plus. What I have to do simply, I have to simply do my ARR of I will be q dot pop the front element, pop the front element. Understand? So this is what I have to do. And return, if return is required, return it, otherwise don't return it. Okay. So I guess you understand the process. So what is the time complexity? Iterating, I am here for entire array. So big of one, big of n, sorry. Again for do for kth time. So k, big of k. Okay, one step I forgot. Like as I said, I have to reduce the value of k. K could be anything, 10 to the power 5 times, right? I don't need to do that many times. So I can simply write k equals to k modulo n. K equals to k modulo n. I can simply write that. Okay. And this is big O of n times, this is of big O of k times, and this is of again big O of n times. So among them, big O of n is greater. So my time complexity is big O of n times. Let me write it down. It is big O of n. It is big O of k. And this k doesn't mean a long k. Yeah, k is reduced. K is reduced. And here is big O of n. Time complexity is big O of n. Space complexity, I've taken an entire cube and its length of size n. So it is a big O of n. Okay. Can I do it any other way without taking any extra data structure, right? Q, or can I minimize this thing some way? Okay, let's see another way. Let's take approach 2. There are multiple approaches. You should not just remember only one approach, okay? You should have learned every approach. It could not be useful here, but it could be useful in other places, right? So please learn as many as approach, and it will help you solve other problem, or you have to help, it will help you to think to approach in other problem, how to do it. Like here you learn about how to use the queue, one element, how to, let's say what I could do is not using the queue. See here I do the 2 times I have to do, and it is my output error. So see this part comes to the front, and after that this part comes to the at the back, right? So for that, what we could do here is, like, see, these two elements comes here, and these three elements come in this place. What is the position of this element? This is the kth index. Okay. So if it is my kth position, so this is what 0, 1, 2, 3, 4, right? So k, it is here 2. This is my k. So from kth position to the end of the list, I can iterate through and add to the new list. Let's say take a new list. This is a new list. From kth position to the end of the array, I can add them, iterate and add them into this. So I can write a loop for, again I need an in equals to ARR of length, length. Then what can I do? As I said, I can start k equals to second position and go to the end of the list. So I can, instead of k, I can write I equals to k, and while my, what is called, I is less than n, while my I is less than n, I is less than n, or I can instead of while loop I have to write 3 lines of while loop. I can write a for loop, right? So for I equals to k is I is less than n and I plus plus, I can do what? I am taking as though I'm doing a vector, okay, vector of this or any array list. So I can simply add into that. So I can write like this is my new ARR, new ARR. So I can write my new ARR dot add append pushback whatever it is, like what I do ARR of my I. Okay, so this is my step. I did that. So my I starting from here and end to here. So up to this many element I add to the new list. So it becomes 3, 4, 5. Okay. Now I have to add what? And then I have to add is what? I have to add what? This element. Okay, these 2 element I have to add. So I have to start the I again starting from 0 to up to which element? Kth minus 1 element. So kth minus 1 element I have to do it. So again before that I forgot that reduce the value of k. So please optimize the kth value. So k will be k modulo n. Fine. So again I have to starting from 0. So for I is 0, I less than n, sorry, I have to do k minus 1 element. So I less than k, then I plus plus. Okay. So what I could do here, like new ARR dot add ARR of I. Okay. So again this is done. So after that I starting from, I told you I starting from here and up to k minus 1. So 1 and 2 will be added. So see, this is my reverse element, like two if you do left rotate by two places, then it is the my actual output. So what could the time complexity? It is running 0 to k, right? Sorry, k to n minus 1, and this is running 0 to k minus 1. So in entirely these two are running 0 to n minus 1. That means n big of n. So both two cases in combined time complex is big O to of n. And also like what we are taking an extra space of this new array taking extra space, right? The time complexity becomes big O of n and space complexity is also big O of n. So you can say it is similar to the fast approach, right? So they are also big O of n, it is also big O of n. See here, here we have, I'm iterating fast, like iterating fast one time, then kth time, then again n time. So it is and at maximum worst case k becomes n minus 1. Okay, so in that case it is also n, so it is big of 3n actually. And here also you said like it is a I create a new array actually. Yeah, obviously I create a new array. So one step I need. So for one step I need big of I equals to 0, I less than 1, I plus plus, and I have to just sorry I plus plus, and it becomes new array, new ARR dot add, sorry, not new ARR, I have to reassign the value actually. So reassign the value means ARR of 0, ARR of I equals to new ARR of I, ARR of I. Perfect. I guess you understand. Okay, and this is also big O of n. So big O of. So it is slightly better approach because here I am iterating 3 times. We are iterating 2 times. So it is slightly better approach. So what could be the optimal approach? What could we do in optimal cases? Let's take an example again. So let's see what could be the optimal approach. So this is my array, right? Now see, notice one thing. If I write it down here, 1, 2, 3, 4, and 5. So if I tell you, so reverse these two parts. reverse this part and this part. Why? I will tell you later. So it becomes, if I reverse it, it becomes 2 and 1. If I reverse it, it becomes 5. It becomes 5, 4, 3, 5, 4, 3. And if I do here, if I rotate the entire array, if I reverse my entire array, it becomes again what? 3, 4, 5, 2, 1. See this? This is actually my output. This is how we could do. So simply we can write the code like I need, and how could we choose my partition? This is starting from k and this is up to k minus 1. Okay, so I can rotate by this. Sorry, reverse by this. So I can do what? I can write my ARR. I have to do what? I have to reverse it, right? So for reverse function, please see the my reverse video. You can see any other video, any other how to reverse an array for a given two position, or you can see my video. I've also explained the reversing thing, so you can see any of the thing. But this is the logic, and I will assume you understand how to know how to do the reverse logic. Okay, so I will do what? I simply reverse what? My ARR, and reverse my what? Starting from first 0 to k minus 1. Okay, and again I'll do reverse. Before that also, let's find out the k and reduce the value of n. Okay, let's find out the k. Sorry, n equals to ARR of length, and k will be k modulo n, and it will be reverse. Again reverse, I am doing what? Reverse of the second part. So ARR starting from k to n minus 1, and again I have to reverse its ARR of 0 to n minus 1, whole reverse, whole the array I have to reverse it. That's all. That is the thing. So this is how we can do it, and this is much optimal. Why I'm saying optimal? If you know the reversing part is, this will take big of k by k 0, sorry, k minus 1 minus 0, or k minus 1 by 2 times. It will take n minus 1 minus k by 2 times, and it is big of n minus n by 2 times. This is the time complexity. So on an average, these two both together, you can see here. I am reversing this element and this element, right? So together also I'm reversing, right? Reversing the array. So it will take together, it will take n by 2 time complexity. So and here it is that big of n by 2 time complexity. So time complexity becomes big of n by 2, and space complexity is what? Big of 1. Are we using any extra space? No, right? So it is big of 1. But that's all. That is the case. Okay. Let's discuss about right rotation right now. For right rotation, take the previous example. This one. Copy. Copy. Yeah. So if I paste it here, this is my right rotation. So if I do right rotation k equals to 1, it becomes what? My 5 will come this side, then everything will shift one side to right. 2, 3, 4. So this is my k equals to 1. And what will happen if I do k equals to 2? So k equals to 2 will becomes like, again it will, this 5, like this 4 comes this side, and the rest of the thing will shift to the right side. So if I do k equals to 2, it becomes 4 comes here, 5 comes here, then shift everything. 1, 2, 3. So this is how it works, right? So now let's see. Yes, also I'm taking the k equals to 2, assuming k value is 2. So this is my final output. Okay, this is my final output, k equals to 2. And after that, what we could do, let's see how could we do it. So as previous, what we could do, if you notice carefully, like even if I don't remove the initial cases, come back here. So if I do what, where queuing technique, right? Queue technique I can use 5. So it is a reverse kind of queue. I have to pop from here and I have to add from here. There. Then again, this is the thing. Again, I can pop from here, I can add into the here. So again, I will get the. But this is not a queue. This is a special data structure called DQ. But DQ, we can push and pop from the both end, and for Q we can only pop from the first and push at the bare end. Sorry, last. But the DQ we can push and pop from the both end. So for that we need a DQ. Okay. So if we take the same thing, I'm not writing the entire thing. It will be exactly same. Let me add. Take the copy. Take the copy. This is the copy. So if I notice, I have to take not dq, sorry, not q, it will be dq. So for that, this is my dq. Okay, so we have to use same thing, but it will be not add, it will be add right or add in, something is there. So I'm saying add right, add right. Okay, add right what? Add right of x. And again, each and every I have to do how many rotation? Kth rotation, right? So up to kth rotation, I will not queue pop from the front. We can say pop from the front or pop from the left. You can see the documentation of that DQ. You can understand what will be the function name. So I will pop from the left, and I will add that to the again add to the right. Add right. Right out what breaks. Okay. Did I do any mistake here? No, I didn't. No mistake. So and k minus 1. Same thing. After that, I have to replace the actual array. So do the pop left. Exactly same thing what we did in the ref rotation. Now, could you see any kind of advantage about right rotation or something? So if you notice what, see this earlier also. After 2 times of k rotation, okay, let's take a fresh page and see this, show you how to what I'm saying. Copy, paste. So if you look at it, like if I consider my k value is 2, this is my final output, right? This is my final output. So if you notice carefully, after 2 return, what is the comes first? 4 and 5. 4 and 5 comes first. Then 1, 2, 3 come here. Okay. Then again, if k equals to 1, then 5 comes here, and rest of the thing will come to here. Correct. So again, we can, what we could do, we can iterate, but iterate for which index? So that's a good question. So here my n is what? N is 5. Now k is what? K is 2. So I have to iterate from like which index is coming in the front? 3, right? So 5 minus k giving me the 3. if my k is 4, k is 1, okay, k is 1, then what is my n is 5 minus 1, this 5 should come at the front when k equals to 1, right? So this is how we have to do, and up to which I have to do. So I have to store this element that up to which I have to rotate, let x equals to n minus k, and I have to do, and second iteration I have to do from 0 to the x element, before the x element actually. Okay, so let's write a pseudocode, you understand what I am saying. So n equals to arr dot length, and I have to do reduce the kth value, k equals to k modulo n. And what I have to do again, I have to do this one, like as I told, from I have to choose a starting point so that I can iterate, right? So iterate, as I told, it is what it is, x equals to, I have to store the value of x, you understand why, or I can x equals to, let's, for you easy, I can do n minus k, so that you can understand easily. I am storing this value in minus k, I can directly use in minus k. So here I have to do what? I have to start for I loop I equals to n minus k, I less than 0, I plus plus, and I have to do what? I have to again create a new array as earlier, new array, and add to this into the array. Yeah, better to do it vector, it will be easy, otherwise you have to do index calculation. So I can doing as a considering as a vector. So vector means new error. Error is what? Sorry, I less than n, not 0. I less than. Okay. So new error dot add append to swag based on our language. Writing add new error add what? Error of I. Right. And I close this thing. And second iteration also I need. So second iteration, so first iteration I is 1, we have to here at the end, so 4 and 5 are being added. Next I have to starting from I equals to 0 to up to what? X less than x. This is my currently x position, x equals to n minus k, and k is equals to 2 here, so n minus k is 3. So I have to iterate for I to I 0 to I less than k, I is less than k, less than x, I plus plus. Is it? It's fine. Let's see. And what I have to do? New error same add, new error of add, error of I. And this is all. After that, again I have to iterate one times, whole times to replace the actual error. If it is given, you have to replace actual error. You can have to replace, otherwise you can return this new error. So I equals to 0, I less than n, I plus plus, and error of, so it will be error of 1, error of I equals to new error of I. As usual, the time complexity is, for both these two cases, it is combined big of n, and for this case it is big of n. So time complexity is uh, big of n, is big of n. Space complexity is what? It is, I'm taking also extra space, so it is also big of n. So after this one, it becomes sorry. After this thing, this 4 5 comes here. Then 1 2 3 will come in this space. 1 2 3. So this is another approach. After that, let's see the actual approach, like optimal approach. For these two cases, big of n, and this case is big of n. So let's see the optimal approach. Let's take this example. So let me copy this. Put it here. Okay, let's take it. Example 1, 2, 3, 4, 5. Now earlier in left rotation we reverse the part of it first. Now in this case reverse the entire thing. So it becomes 5, 4, 3, 2, 1. Again now let's rotate for first k minus 1 elements. So it becomes 4 and 5. And again we rotate these two elements, like last from kth element to n minus 1 element. So it becomes uh, 1, 2, 3. 1, 2, 3. So you can see these two output are exactly same. So what will be the code for that? Simply I made n equals to arr of length, arr of length, and k will be, as I told you, that it is the value of k, and then reverse the array. So first I have to reverse the entire array, reverse the entire array, like what reverse my arr with entire array 0 to n minus 1, and reverse my array, then how 0 to k minus 1 place, right? 0 to k minus 1 place. As I told you, I have to reverse. After hold reverse, I have to do 0 to k minus 1 place, then k to n minus 1 place. So reverse of arr of 0 to k to n minus 1 place, k to n minus 1 place. So this is the code, and again this is big of n by 2, and this is also together is big of n by 2. So overall time complexity is big of n by 2. Big of n by 2. So time complexity becomes big of n by 2, and space complexity we are not taking any extra space, so big of 1. So this is the code of right rotation. So let's see what we could do if we find out any relation between left and right rotation. Okay. So if my array is if my array is 1, 2, 3, 4, and 5. The left side I am doing left rotation, and right side I am doing right rotation. So how to the left rotate? Left rotate, if I do left rotate k equals to 1. This side, let's say I will do left rotate. Left rotate. This side I will do right rotate. Right rotate. So if it is to k equals to 1, it will say 2, 3, 4, 5, and 1. If I do k equals to 2, it looks like 3, 4, 5, 1, 2. k equals to 3 means 4, 5, 1, 2, 3. K equals to 4 means 5, 1, 2, 3, 4. 5, 1, 2, 3, 4. And k equals to 5 is the actual array. Okay, so I'm not doing k equals to 5 because it is the actual array. So if I do right rotate, then k equals to 1 means it is what? 5, 1, 2, 3, 4. K equals to 2 means 4, 5, 1, 2, 3. K equals to 3 means 3, 4, 5, 1, 2. And k equals to 4 means uh, 2, 3, 4, 5, and 1. And k equals to 5 is actually the same. So if you notice carefully, here k equals to 1 is exactly same as k equals to 4 here. Okay. Again here k equals to 2 is exactly same as k equals to 3 for right rotate. Similarly, k equals to 3 in left rotate is equal to k equals to 2 in right rotate. So that is the one pattern. So if I see any pattern, so what can I see? Like if I merge this one, this I can see this one is similar to this one, right? So 1 plus 4 is what? 5. And 2 is similar to 3. The 2 plus 3 is 5. So 5 is what here? 5 is actually the length of the array. So if they are saying, there is a thing like if I do k equal to x left rotate is equivalent to n minus x right rotate. Okay. Similarly, if k equals to x right rotate is similar to n minus x left rotate. So it doesn't matter. You don't have to remember two different logic. Just remember one logic, understand one logic, and simply by using this thing, you can convert left rotate to right rotate. Similarly, we can do uh, that what is the thing like right rotate to left rotate. The same logic. This is how you could do. I'll now try to do the same thing. If you do the left to right rotate formula, just if you want to, if they have set to left rotate, but you are using right rotate formula, simply do here in this after this k module n do k equals to n minus k. So if you do that, it will become so left rotate. Similarly, for the left, if you are using left rotate formula, but you want to do right rotate, similarly we can do k equals to n minus k. Same thing you could do. So this is how you could do. So this is the pseudocode. Try to write. It is a very simple basic code. So try to write your code on your own language. I'll provide all the code in the GitHub, commented in the description. You can see that code. But code is in Python, not in C++, Java, or any other language. So that's why I write the entire time I write a pseudocode. So try to write your own code. I guess from the pseudocode you can easily write your own code. Yeah. Okay. As well as if you find any mistake here, please comment it down so that I can rectify. And if you find any useful video on this topic, please also comment it down so that I can also learn the new logic. Okay then, bye bye.